Here we have the graph of two exponential functions. On the right in blue, we have the exponential function y equals 6 to the x power. On the left, we have the exponential function y equals 1/6 to the x power. You should notice a couple things about these two graphs. First, they have this intersection point at the point 0, 1. Because when we substitute 0 into either one of those functions, anything raised to the power of 0 is 1, so we get 1 as the output. It makes sense that they intersect there. You will also notice that these two graphs are reflections of each other over the y-axis. The y-axis serves as an almost line of symmetry for the two of them fit together, if we think about the two of them fitting together. The real question as to why that happens stems in the relationship between these two equations. This one should be fairly straightforward. As x increases, we should expect y to also increase. And we get this big rate of increase here that's multiplicative in nature. For every 1 in the input, we're multiplying by 6. 6 times 2, 6 times 6, 6 times 6 times 6, 6 times 6 times 6 times 6. We're getting an extra factor of 6 every time we raise the value of x. Over here, though, as x increases and the values of x get larger, we should expect this function to dip down towards 0, which is what happens as it goes this way. Instead of getting an extra factor of 6 for this exponential function, we get an extra factor of 1/6, which is going to force the value of the function smaller and smaller and smaller as we raise the value of x. And incidentally, if you reverse this, the reverse happens. And if you send this to negative infinity and you think about smaller and smaller values of x, that's where you're going to get your 0, because then it'll turn into division. And as this goes towards negative infinity, that's where you're going to get this shockingly large growth that's reflective of y equals 6 to the x. So the question becomes, why does this happen? Why do these two functions have this relationship where they are reflections of one another over the y-axis? The easiest way to see it is to remind yourself of what it means to be a reciprocal. One of our defining characteristics of a reciprocal, which is what we have here, 1/6 on this exponential equation, one of the defining characteristics of being reciprocal is that you can be that number raised to the -1 power. Once we have 1/6 written as 6 to the -1, still not a negative base, we multiply the two powers together and we get 6 to the -x. Compare that to the 6 to the positive x, and we should see why this is a reflection over the x-axis. All of the numbers here that made this function large will make this function small, and vice versa. The two sides of the x-axis have now been flipped when you consider these two functions against each other. So you should anticipate reflections over the x-axis not to be some magical change that we can make to the function, but instead having that reciprocal relationship between the two of them, where we reverse that relationship from one of them to create the other.